Hello everyone. In this video, we will learn how to use pseudocodes, how to express algorithms using pseudocodes, a powerful way to design logic before writing actual code. So, pseudocode is nothing but a way of expressing algorithms, a way to express algorithms. Okay. Pseudocode is a high level, first we will look into the definition. Pseudocode is a high level, human readable description of an algorithm that uses the structure of programming languages without strict syntactical rules. It helps us express our logic clearly and abstractly before implementing it in the actual code. So, what exactly is a pseudocode? Pseudocode is nothing but a simple, readable and structured description of an algorithm. It uses plain English and common programming keywords. Okay? It uses plain English and common programming keywords. But it will not follow strict syntactical rules. It helps us focus on logics of our solution rather than syntax. So pseudocodes focus on logic, rather than syntax. Okay. Syntax. Point to be noted. So here we have already gone through general guidelines for writing pseudocodes. As we have already discussed, uses plain English to describe steps, uses standard keywords or regular keywords like start, end, input, output, conditional loops like if, else, while, per, repeat, until, etc. and indented blocks to show structure or modularity. And also we have discussed that it uses loops and conditionals also. Focus on logic rather than syntax. So it majorly focus on logic rather than syntax. Avoid language specific features. So it just only follows a logic with simple English rather than a language specific feature or syntax. So what are the benefits of the pseudocode? Benefits of pseudocode. It clarifies thought process. So as we are going for a simple plain text steps, it clarifies our thought process. Okay, first thing. And second, helps plan our program before we code. So we'll plan our program, planning the program before coding. Planning program before coding is one more benefit. And a third benefit is that makes it easy to discuss algorithm with others or peers. Peer discussion is made easy using pseudocodes. Peer discussion made easy using pseudocode. And what is the another benefit? Reduces coding error during implementation. As we are planning ahead and clarifying our thoughts, we can reduce errors before coding. Reduce errors before coding. Okay, before coding, sorry. Here are few examples of the pseudocode and formatting. First we'll look into the general structure, basic examples. So basic examples include start, end is the first step. This is the first step, and start will be the first step and end will be the last step. Input, we can declare and initialize input variables. Output, to store the result or a message or result. Assignment, setting values to the variable, setting values to the variables declared here. And few conditional statements can be used, like if, then, else, and if, or loop statements. These are all statements, conditional and loop statements. And functions like procedures can also be used in the pseudo codes. Okay. This is the general format. General format. So we'll look into the few examples one by one. First example is first step is start and final step is end, which is common in every pseudocode. And here we are taking input variables as number 1 and number 2, variable 1, variable 2. And final variable is sum, which we are storing number 1 and number 2. We are adding and storing in the variable sum. Here in this case we are declaring and initializing at the same step. So sum is the variable here, where number 1 and number 2 are added and stored in sum, and the output result is printed onto the screen. So this pseudocode reads majorly two numbers, adds them and prints the results. It reads the two numbers, adds them and prints the output variable sum. Next, second example is as usual first step, final step. Here we are using conditional, simple condition, if, else and if. Okay, a simple condition. If, else and if is the simple condition to compare two values and print the larger one. So first value is A and second value is B, and we are comparing them. Here the comparison is going on, and if A is greater than B, then we are printing A, else we are printing B. So finally what is the logic? Printing the largest number. Okay, printing the largest number using a simple condition. Okay. So the next one is calculate factorial. Here we are using a for loop to multiply values from 1 to n. So what is the meaning of factorial? Multiply the numbers from 1 to n to find factorial. This is the logic going on here. So first one is maximum number, that is n. Set factorial, this is the variable here. So first initially we are setting factorial variable to 1. We are using a for loop here explicitly. for loop is used here. So for loop is used so that it will traverse from 1 to n, 1 to n, and we are setting factorial variable is equal to factorial into 1. First time it sets to 1, so first time it will multiply with 1 into 1, that is 1 and 1 here. So initial loop factorial is 1 and I is also 1, so factorial becomes 1 and n for, and again it will add plus 1 and then it will go to 2, so 2 into 1 and again it will go to 3, 3 into 1 and so on. Finally it will find the factorial. Output variable stores the factorial and prints the factorial value. Okay. Next is linear search pseudocode. Pseudocode for linear search. What this example does is that it shows how to use a loop and conditionals to search for a target value in the list. So we have a target value and we want to find that in a list. Okay. So this example shows us how do we use per and conditionals and loops to find out the target in the list. So there is a list here, size of the list and the target element. So we are using a variable found is initially false for I is equal to 0 to size minus 1. So the in the list size will become n minus 1 element. So from 0 to size minus 1, it will search in the list, for example 0 comma comma so and so, size minus 1, it will search for the list I, which is the element number. What is the position? This indicates the position is equal to target, then output element is found. For example, listen. In here I am taking an example. There is a list called 0, 1, 2, 3, so on 4, 5, and so on 10. And the size in this list I am searching for per number this element. This is my target. Target is 1. For the list 0, it will search and it will not show that element is found. It will go for the next element and say searches for 1. If the element is found, it displays the output as element is found at position, second position. Okay, this is the second position. 1 is preceding at the second position, so it will show second position. If the element is not at all found, for example I am giving 20, if the element is not at all found, it will break from the loop and will go for, if found is still false, if found variable is still false, then it will show the output as element is not found in the list. Okay, this is how linear search is working with loops and conditionals. So what is a pseudocode? Finally, pseudocode bridges the gap between conceptual logic and real programming. What is conceptual logic? It is nothing but an algorithm. Okay, pseudocode bridges the gap between conceptual logic and real programming. It enables clear communication of algorithmic steps, especially in teaching, planning and peer discussions. This is one of the benefits of pseudocode. This is a very valuable tool used in teaching majorly and programming. It helps focus on what our algorithm does rather than how it's written in code. Mastering pseudocode will strengthen our problem solving skills. It will strengthen our problem solving skills and make the transition to code much easier. So one of the benefits of pseudocode is transition benefited from algorithm to code. Transition made easy. I hope you understand what is pseudocode. Thank you.